The topic that I'm gonna discuss is about continuity. I made two problems about it. But first, what is continuity? A function is said to be continuous if its graph has no breaks or holes and you can trace it without lifting your pen. A continuous function is defined for any real number. So, for the first problem, it is determine if f of x equals x squared plus 4x minus 2 over x minus 2 is continuous at x equals 1. So 1 is a real number. So if you're gonna input the function at Desmos, we will see that it created a hyperbola. Yes. So it doesn't have any breaks or holes. And if we analyze it more further, x equals 1, we will see that it met. The points are 1 and -3 for the y-axis. So it is continuous at x equals 1 because it doesn't have breaks or holes in that point. As for the equation number 2, the second equation, second problem, it is a piecewise function where f of x is equals to 3x plus 5 if x is less than or equal to. Next function is x minus 3 if x is greater than 2. x equals minus -4. So in order to prove this, so the question is x continuous or discontinuous at -4? So if we're gonna input this in the graph, it has two lines, and as you can see, it jumped at the two lines because it is a piecewise function, so it consists of two lines, two graphs. So according to the definition or the description about continuity, if you can see in this graph, it is automatically discontinuous because it jumped. You cannot trace it at the point 2 in the x-axis. But that's not the question. That's not what we are asking for. The question is about if it is continuous at -4. And if we analyze the graph, the first equation is continuous at -4 because it met and the points are -4 and -7. So it is continuous there. But as for the 2, it isn't.
So we can now proceed to the second problem, which is limit of x as it approaches to 0 tan x over 2x. So again, let u is equal to x. When x is equal to 0, then u is equal to 0. We will divide the equation 2 over x over tan 2x to 2 over 2. And it will become 2x over tan 2x times 1 over 2. And then we will substitute the 2x into u, and u over u is equal to 1. So 1 over 1 times 1 half is equal to 1 half. So the problem, limit of x as it approaches to 0 tan x over 2x is equal to 1 half.
Have you wondered if the center of the flying fiesta suddenly disappeared in the middle of this rotation? Where would the riders fly? Without the centripetal force, the riders will fly in a line that only touches the rotation once. This line is known as the tangent line, or the slope of the tangent line, and we could actually compute its equation. The value of m, or the value of the slope, can be determined through the equation. M is equals to the limit as x approaches a, function of x minus function of a over x minus a, while the equation can be computed through y minus function of a is equals to m times x minus a. For example, the slope of the tangent line of the point 80 in the parabola x squared minus 64 can be computed as follows. Substitute the function of a, the function of x, and the a. Now, we have to simplify each terms and factor out the numerator. Cancel the following terms and then substitute the value of x. Now we know that the value of m is equals to 16. To determine its equation, substitute the function of a, the m, and the a. Distribute m and transpose function of a. Now, we have to combine like terms and we are done. The equation for the slope is as follows. Y is equals to 16x minus 128. Another example will be the parabola x squared plus x minus 30, given that x is equal to 6. To find function of a, we simply need to substitute the value of x to the function of x. We now know that the value of function of a is equals to 12. Continuing, substitute the function of x of the parabola, the function of a, and the a. Simplify each terms and combine like terms. Then factor out the numerator. Cancel the following terms and distribute or substitute the value of x. Now we know that the value of m is equals to 13. To find its equation, substitute the function of a, the m, and the a. Distribute m and transpose function of a. Combine like terms and we are done. We now know that the function or the equation of the slope will be y is equals to 13x minus 66. Now we can compute where the line or the equation of the line of the riders will go.
Good morning everyone, and now we will tackle the topic involving derivatives. Derivatives involves multiplying the constant to the exponent and reducing the exponent by 1. For our first example problem, we have 10x raised to 5 plus 4x cubed plus 5x plus 24. As stated earlier, we will multiply the constant to the exponent. So in our first term, 10x raised to 5, it will become 50x raised to 4 because 10 times 5 is 50, and then x raised to 5 reduced by 1 will be x raised to 4. On our second term, 4x cubed, it will become 12x squared because 4 times 3 is 12, and then x cubed reduced by 1 will be x squared. And then the third term, 5x, we will have 5 because 5 times 1, which is the imaginary exponent of x, will be 5, and then the x will be omitted, so we will have 5. The number 24 in our equation will be omitted because it does not have any variable and exponent attached to it. Our final answer will be 50x raised to 4 plus 12x squared plus 5. And now for our second problem, we have a much more longer and complicated way of solving. 7x raised to 7 plus 9x raised to 5 plus 3x raised to 4 plus x cubed plus 2x squared plus 4x plus 25. Our first term will be 49x raised to 6 because 7 times 7 is 49, and then x raised to 7 reduced by 1 will be x raised to 6. Our second term will be 45x raised to 4 because 9 times 5 is 45, and then x raised to 5 reduced by 1 is x raised to 4. Our third term, 3x raised to 4, will be 12x raised to 3 because 3 times 4 is 12, and x raised to 4 reduced by 1 will be x cubed. Our fourth term, x cubed, will be 3x squared because there is an imaginary 1 constant and then 3. 1 times 3 is 3, and then x cubed reduced by 1 is x squared. Our fifth term, 2x squared, will become 4x because 2 times 2 is 4, and then x squared reduced by 1 will only become x. Our sixth term, 4x, will become 4 because 4 times 1 is 4, and then the x will be omitted. For our last term, number 25, it will also be omitted because it does not have any variable nor exponent attached to it. Our final answer will be 49x raised to 6 plus 45x raised to 4 plus 12x raised to 3 plus 3x squared plus 4x plus 4.
The letter A, so if you factor the top and bottom, you see the denominator is 0 at 5 and at 3. So those are points where the function doesn't exist, certainly can be continuous. Everywhere else, we can cancel the factor of x minus 5 from the top and the bottom. And so we got that the function is this except at 5 and 3. The function doesn't exist at 5 and 3. It's continuous from negative infinity to 3 and positive 3 to positive 5 and 5 to minus 5 from the top and the bottom. And so we got that the function is this except at 5 and 3. The function doesn't exist at 5 and 3. It's continuous from negative infinity to 3 and positive 3 to positive 5 and 5 to positive infinity. It's continuous everywhere except at 5 and at 3 infinity. It's continuous everywhere except at 5 and at 3. Letter B, in continuity on an interval, it's continuous from negative infinity to negative 3 and negative 3 to negative 2 and negative 2 to infinity. The function doesn't exist at negative 2 and negative 3. It's continuous everywhere except at negative 2 and negative 3.